Hi, my name is Alex, and I am section 0103, and this is my ENES102 final project. And my structure, my machine that I decided to do my project on was an ice cream scoop. Okay, so the introduction to the ice cream scoop. As you can see, there's a picture right there, and essentially, ice cream scoops are little machines, little spring-based machines that are designed to quantify and pick up a little ball of food. It can be usually ice cream or gelato, or it can be anything like mashed potatoes, tuna, I believe, which is in this picture right here, anything long sorts. And the reason why I chose this is because I have worked in an ice cream shop for roughly 3 years. As you can see, that is a picture of me back in high school with an ice cream scoop. And I thought these were engineeringly fascinating. Mostly because they were simple, they were easy to produce, they were easy to maintain, they were reliable. They checked off all the check boxes for any engineering prototype. And yeah, so let's dive into the structure slash the system modeling. Essentially, this is broken down in. This is a picture of a ice cream scoop, of course, and it's broken down into 4 parts, 5 parts if you include the spring. And I actually have the diagrams right here. The entire thing is 9.375 inches. And so essentially, it's broken down into 4 parts. You have the handle right here, which is blue. Well, it's blue in the diagram, in the picture. But usually it's just used for picking up the scoop. You have the scraper piece and the cog right here. This is used with the lever. The teeth of the cog, which are right here, come into contact and kind of align with the pattern of slits right here. And that is essentially what makes this entire thing rotate this way. Oh, what did I do? Okay. Then you have the bowl itself. This part is used primarily just to scoop up the ice cream, gelato, etc. And then you have the spring. The spring is within the thing itself, within the scoop itself. It actually lines up like this end right here, lines up into here. So essentially, this spring is always in contact with this lever piece. And so this diagram shows the spring in its resting state, this entire scoop in its resting state. The lever is erect, it's out, it's in its regular position. But once you apply some sort of force to it, you get moment equations, and this is where that 2D/3D equilibrium comes into play. Because once you take the moment about the origin, this is the origin of the spring itself. You have 2 opposing forces, the spring, the natural spring force, and then the force applied. And then, of course, the force applied usually would want to overcome the spring force. And then this moment is actually translated into the scraper piece itself. And this moment force is actually what makes this entire scraper piece rotate in this direction. Rotate about this axis. And when it rotates about its axis, this is what separates the food from the bowl itself. And of course, you have to consider the material properties. This entire thing is made of stainless steel. So we have the material property right here, the elastic modulus. And then this point right here, this little cube diagram, is representative of the point where the scraper comes in contact with the bowl itself. And so this is kind of like the normal force of the bowl is opposing the normal force of the scrape. And you have the dimensions right here. And so you have the deformation that the spring causes on this little cube part, which is 6.8027 times 10 to the negative 8 inches, which is roughly 17 nanometers. You have the breakdown of how the spring stops how the cog stops the spring, the lever piece, from going any further because it comes into contact. And yeah, so these are my calculations. Essentially what we calculated is that there is a 2-pound input and then a roughly 3-pound output, which is really nice because you never want to apply too much. You don't want to apply too much force to an ice cream scoop, but at the same time, you want to have a good outcome. And yeah, these are my resources, and thank you.